Okay, so today's day 8 of Unit 6. We started today just right away with the notes. Um, and for the notes, you'll need your notebook, but also your packet. So we started with this example that we didn't get to yesterday, example number 3 on page 14. So remember, we start every problem by factoring and simplifying if we can. So looks like the numerator does not factor, but the denominator does. So looks like 3 and 2, and looks like plus 3 and minus 2. Yep, so looks like that does not simplify though. It factored, but it didn't simplify. So now I know that there are no holes because there are no common factors. So next I'm going to work on the vertical asymptote. I'm setting x plus 3 times x minus 2 equal to 0 and solving. I'm getting two real values, x equals negative 3 and also x equals positive 2. So that means that there are two vertical asymptotes, one at x equals negative 3 and the other at x equals positive 2. So I'm going to go ahead and plot those. Next, I'm going to get the horizontal asymptote. So remember how we check that. Checking the degrees of the numerator and denominator, they are the same. So when the degrees are the same, then the horizontal asymptote is y equals the leading coefficient divided by the leading coefficient. And there's no number to worry about on the end there. So it's just y equals 1 divided by 1. So for the HA, y equals 1 over 1, and that just gives me y equals 1. So that's the horizontal asymptote. Plotting it, labeling it. Okay. Next, we're going to work on the x and y intercepts. So let's go ahead and get those. So x-intercept, substituting 0 in for y and solving for x. Now remember, you can use the original or the factored form. It doesn't really matter. Now, had we been able to simplify, we would use the simplified form. But I wasn't able to simplify other than just factoring. So either is fine, the original or the simplified. I think I'm just going to use the original. So 0 in for y. So putting the 0 over 1, I'm allowed to do that. Cross multiplying 0 is equal to x squared plus 6, which I can use square root technique. Negative 6 equals x squared. I'm already noticing I'm taking a square root of a negative, so I know absolute value on the right, but I root 6 on the left. So plus or minus I root 6 equals x. So remember, I'm trying to find x-intercepts. I just found that there are no x-intercepts. Okay, because I can't graph imaginary numbers on the real coordinate plane. Y-intercept. So y-intercept, putting 0 in for x, gives me 6 over negative 6, which gives me negative 1. So 0, negative 1 is the y-intercept. So let me plot that. Okay, so now this clearly is going to be a different graph than what we saw previously, what we saw yesterday. So because I know that because of the two vertical asymptotes. So I had students put in their notebooks a few notes. So you want to find some space to take some notes. I'm just going to extend the page here. I'm just going to put it separate for a moment, and then we'll go back to that graph. So when that happens, when you have two vertical asymptotes and one horizontal, there's a couple different ways the graph could look. And actually, there are several different ways the graph could look with two vertical asymptotes and one horizontal. We're going to focus on just 4 different ways that the graph could appear. So the first option in this, like I said, we're just going to focus in this class on 4 different ways. The first option, if this is my horizontal asymptote and these are my vertical, one way that the graph could look is what almost looks like a parabola in the center section, lower center section, and then what almost appear to be sort of like the hyperbola curves in those two sections. So that's option one. Option two looks kind of similar. It has two vertical, one horizontal asymptote, and we have almost what looks like a parabola. Again, these are getting closer to the asymptotes, the vertical asymptotes, and then we have what almost are like the curves for hyperbolas in those two corners. And again, they're getting close to that asymptote on each side, the verticals. So that's another way it could look. Number three, again, we have the two vertical asymptotes and the one horizontal, and we have what appears to be almost like a cubic. So it'll have like a point of inflection somewhere there. And remember, this is not the x-axis, this is the horizontal asymptote. So we have that in the center, and then we have these curves that almost look like hyperbolas again, the hyperbola curve in these two regions. So that's another option. And the last option that we'll sometimes see here in Algebra 2 is, again, two vertical asymptotes and one horizontal, and then what looks like a cubic going in the opposite direction, and then again what look like hyperbola curves in those two spots. So those are going to be your options that it could possibly be. So, and like I said, they're not the only options, they're just the only options we're going to focus on here in Algebra 2. In pre-calc, you'll look at some other options for the graph. So if I'm comparing these four options with my information that I have, we said no x-intercept, and we said 0, -1. So I should be able to eliminate a couple possibilities here. So if there's no x-intercepts, well, options 3 and 4, because of that what looks like a cubic shape, it's going to eventually cross the x-axis. Remember, this is the asymptote, not the x-axis, but anywhere I put the x-axis, that part in the center is going to cross the x-axis. So 3 and 4 are out. Comparing 1 and 2, they could possibly not have x-intercepts, so that's okay. But then 0, -1, 0, -1 would be down here, okay, which means I'd have a part of a graph below the x-axis, which means I'm going to expect our graph to look like option number 1. Okay, so I already have that 0, -1. I'm going to go ahead and plot that. Now, even though it sort of looks like a parabola, back to that curve just for one more second here, it's not actually a parabola. I don't know necessarily that this point that I found so far, I don't know if that's the highest point of that U shape. I don't know if that's the peak or not. So you can't assume that. But what I am going to require of you is that for the center part of the graph, whether it's that U shape or the S shape, you're going to need 3 points. So we already have 1, we need 2 more for the center. And then the other 2 sections that look like hyperbola curves, same as the hyperbola, I'm going to require 2 per curve, 2 points per curve. So we need to get several points here, and we're going to do that now. We're going to focus on the center section first. So let's get our XY table set up. I can't use 0 because I already have that. I want something between -3 and 2. So I'm probably going to use -1 and +1 because they should be nice and easy. So let's see what we get when we substitute in -1 and +1. So I'm getting, I'm putting in the original -1 squared plus 6 over top of -1 squared minus 1 minus 6. So that gives me -1 squared is 1, 1 plus 6 is 7, and in the denominator -1 squared is 1, 1 minus 1 is 0, and 0 minus 6, -6. So -1 gives me -7, 6, which is -1 and 1/6. So -1 just a little bit below -1. So here I am, -1, just a little below -1, right about there. Okay, now remember what I said a moment ago about it. It's not necessarily a parabola. It doesn't have the same properties, so I can't just do the mirror image of this point like we could when it was a parabola. So I do need another point. So I'm going to substitute 1 in. So 1 squared plus 6 over 1 squared plus 1 minus 6. So 1 squared is 1, 1 plus 6 is 7, 1 squared plus 1 is 1 plus 1, which is 2, 2 minus 6 is negative 4, so negative 7/4, which is negative 1 and 3/4. So at 1, negative 1 and 3/4. 1, negative 1 and 3/4, so that's almost negative 2. So you can see those clearly, even though the from 0 to negative 1 and 0 to 1, that's the same distance apart, they're clearly not a mirror image, which means that probably that point there is not the peak, the highest point of that U shape. But all I'm requiring is that you have 3 points, and then the asymptotes, you'll use those as a guide. So I am going to just go through those points and approaching the asymptotes and not touching. So there's my first part of the graph. Now I know that I need the other 2 sections on the left and on the right. So I'm going to pick values for x that are smaller than negative 3 and larger than positive 2. So let's see. I'm running out of space here. So I'm looking for values that are smaller than negative 3. So let's try negative 4. So negative 4 is going to be squared plus 6 over top of negative 4 squared minus 4 minus 6. So negative 4 is 6. Negative 4 squared is 16. 16 plus 6 is 22. Negative 4 squared is 16. 16 minus 4 is 12. 12 minus 6 is 6. 22 6 is 11 thirds. 11 thirds is 3 and 2/3. 3 and 2/3, yep. So negative 4, 3 and 2/3. So negative 4, almost 4. So negative 1, 2, 3, 4, 1, 2, 3, almost 4, right about there. Okay, and that is in the region that I expected it to be in. If you get some point that's down here, you know you did something wrong because we are expecting it to be in that region since it's option number 1, the graph number 1. So I know I'm doing everything correct so far. I'm going to continue on with maybe negative 5. So negative 5 is squared plus 6 over negative 5 is squared minus 5 minus 6. So that's 25 plus 6 is 31. And 25 minus 5 is 20. 20 minus 6 is 14. 31 14ths is 2 and what? 20, 30, 3 14ths. 2 and 3 14ths. So just a little over 2. So negative 5, just a little over 2. Negative 1, 2, 3, 4, 5. Just a little bit past 2, right about there. And I have my 2 points. I have the asymptotes as a guide. So through those 2 points and approaching both asymptotes. Now I need the last 2 points in the section on the right. So numbers that are larger than 2 is what I'm going to be substituting in. So we can try 3. So I have 3 squared plus 6 over 3 squared plus 3 minus 6. So that gives us 3 squared is 9. 9 plus 6 is 15. And then 9 plus 3 is 12. 12 minus 6 is 6. So 15 sixths is 5 halves, which is 2 and a half. So 3, 2 and a half. 1, 2, 3, 1, 2, and 1/2 right there. And it is in the section that I expected, so that's looking good. And let's try 4. Let's see. I'll just put it here. So 4 squared plus 6 over 4 squared plus 4 minus 6. So 4 squared is 16. 16 plus 6 is 22. 4 squared is 16 plus 4 is 20. 20 minus 6 is 14. So 22 over 14 is 11/7, which is 1 4/7. So 4, 1 4/7. So 4, that's just about 1.5. 1, 2, 3, 4, 1 and about 1/2. Whoops. Did we do something wrong? Let me check that. 16 plus 6 is 22. Oh, I put it in the wrong spot. I didn't do something wrong. It is 4, almost 1.5. I just didn't place it in the right spot. Oh, I see. I accidentally put, whoops. I accidentally put the horizontal asymptote 1 too high. That's not y equals 1. That's y equals 1. Okay, so let's disregard that original horizontal asymptote. Let me erase that. I accidentally put it at y equals 2. Okay, but we're still okay on, and actually let me erase part of this curve here then. Technical difficulties. All right, so we had that point, we had that point. We're just going to make it go down a little bit lower, closer to that y equals 1 horizontal asymptote. Okay, and now we were at, we had this point here, and we had this point here, and now we're going to approach the vertical asymptote through those 2 points, approach the horizontal asymptote, and now it looks good. We have y equals 1. We have our y-intercept 0, -1, no holes, and x-intercept none, so we are done. Okay, so that takes care of that one. This one we also did in class, and just go ahead and add this to your notes. So step 1 we know is factor. So I think -3 and +1. Even though that factors, there's no common factors, so that means no holes. Now, keep in mind, any of those 4 options from the last slide, from the last problem that I told you, it could be any of those graphs, they could have holes. Okay, so just because we didn't in these examples doesn't mean they don't. Sometimes you will have in that what looks like a parabola shape or the S shape, or even the curves on the ends. They can have holes, 1 hole or more than 1 hole. So just be aware of that. But I don't have any here because no common factors. So now I'm ready for vertical asymptote. I set the denominator equal to 0, and because I have x plus 1 and x minus 3, I'm getting, once again, 2 vertical asymptotes. So let me write those. X equals -1 and x equals 3. Be sure to write the equations because those are lines. I'll try to put them in the right spot this time. X equals 3 and x equals -1. Okay, so next, horizontal asymptote, checking the degrees, they're the same. So like the last problem, when their degrees are the same, leading coefficient divided by leading coefficient, which is 1 divided by 1, which again is 1. So y equals 1. Let me make sure to put that at y equals 1 this time. There we go. All right, next. So because of the 2 vertical and the 1 horizontal, I know it's going to be one of those 4 options from the last problem that you put in your notebook. So let's decide which it is by finding the intercept. So if I find the y-intercept, I'm substituting 0 in for x. Which gives us 0 over -3, which is 0. So 0, 0 is the y-intercept, and I'm also recognizing that means that it's going to be an x-intercept as well. So let me plot that. Okay, now, even though I found the y-intercept, which I realize is also the x-intercept, I can't just assume that there's only just 0, 0. I do have to do the algebra to find the x-intercepts because there could be additional x-intercepts besides just 0, 0. So 0 in for y. I'm going to use the factored form here. Remember, I can use either, but I think the factored form is going to be easier. So putting the 0 over 1, I'm allowed to do that. Cross multiplying x times x minus 5 times 1 equals 0. And then solving x does equal 0. We just confirmed that. But there is an additional x-intercept at 5, 0. So I'm going to add that to my list of x-intercepts. And I'm also going to plot that. So right there. So if I'm looking at what I have compared to those 4 options of graphs, I can tell that this is going to be option number 3. I can go back to that a moment. So because we had a point down here in the lower right and also a point in the center lower, that means it's going to have to be option 3. The others, none of the others will work. So that's what I know to expect. So that means I'm going to need some other points here in the center, 2 more points, 1 more point on the left, and 2 more points on, or I'm sorry, 2 more points on the left, 2 more in the center, and 1 more on the right. So why don't we work from right to left? Let's get the other point there on the right. So I want numbers that are larger than 3, and I don't want to use 5 because I already have 5. So I don't know, how about 4? So we're taking 4 and squaring it, and we're doing minus 5 times 4 over top of 4 squared minus 2 times 4 minus 3. So that's 16 minus 20 is negative 4 over top of 16 minus 8 is 8, and 8 minus 3 is 5. So 4, negative 4/5, so that's almost negative 1. So 1, 2, 3, 1, 2, 3, 4, almost negative 1, right about there. And that looks good. It's where I expected it to be. So I'm going through that point, close to the asymptote, close to the asymptote. There we go. We'll label our x-intercept 5, 0. I'm going to go ahead and label 0, 0 for my x and y intercept as well. So we need 2 more points here in this center section. I can't use negative 1, but I can use 1. So let's go ahead and use 1. That looks like a nice value to try. So 1. So 1 squared minus 5 times 1 over 1 squared minus 2 times 1 minus 3. So that's 1 minus 5, which is negative 4, over 1 minus 2 is negative 1. Negative 1 minus 3 is negative 4. So negative 4 over negative 4 is 1. So 1, 1, that's quite nice. Now, that is on the horizontal asymptote. Now, that's okay. Don't panic. Remember, an asymptote is when a curve approaches, gets really, really close to, oftentimes does not touch. But remember, I said there are some times where the curve will touch or cross the asymptote. That's going to happen here in this case. So that's okay that that's crossing the horizontal asymptote. Not a problem. So I just have 1, 1 there, and I have 0, 0 so far. So now I need 1 more point so that I can figure out how to make that S shape. So I'm thinking maybe 2 would be a nice value to try. So 2 is going in, 2 squared minus 5 times 2 over top of 2 squared minus 2 times 2 minus 3. So 2 squared is 4, 4 minus 10 is negative 6. And 2 squared is 4, 4 minus 4 is 0, 0 minus 3 is negative 3. Negative 6 divided by negative 3 is 2. So 2, 2, right there. Now we have our 3 points, and see how they're in a diagonal. That tells us that we're going to have that S shape, almost like a point of inflection. So the one that's in the center of the 3, that's the one I'm going to make the curve coming out of and going into. So I know it's going to come out of, get close to that asymptote. I'm going to make it almost look like a point of inflection, so going out the opposite direction that it came and getting close to that vertical asymptote. So my cubic looking piece is complete. I now have all 3 points. Next, we're going to get the last piece over here on the left. So we're going to use values for x that are smaller than negative 1. So why don't we try negative 2? Let's see here. I guess I can make my table over here. So negative 2. So negative 2 squared minus 5 times negative 2 over negative 2 squared minus 2 times negative 2 minus 3 gives us 4 plus 10 is 14. 4 plus 4 is 8 minus 3 is 5. 14 fifths is what? 2 and 4 fifths. So negative 2, 2 and 4 fifths. So negative 2, 2 and 4 fifths right there. And I guess I'm going to try negative 3 as well. So negative 3 squared minus 5 times negative 3 over top of negative 3 squared minus 2 times negative 3 minus 3. So negative 3 squared is 9. Minus 5 times negative 3 is plus 15. So 9 plus 15 is 24. Divided by negative 3 squared is 9. 9 plus 6 is 15. And 15 minus 3 is 12. So 24 divided by 12 is 2. So we have negative 3, positive 2. That's easy. So negative 1, 2, 3, positive 1, 2. And that's where we expect it to be. Getting close to the asymptote, going through that point, and that point getting close to the vertical asymptote. And we have the x-intercepts labeled. We have the y-intercept labeled. And we have our asymptotes labeled. And that's it. We are done. So for homework, kind of a hodgepodge assignment here on page 16, number 9, worksheet 2, problem number 8, and worksheet 3, problems 2 and 3. Give those a try, of course, without a calculator. Next week on Wednesday, you will have a quiz without a calculator.